C6 booklet, foundation questions. Question number 1, electrolysis is the answer. Part B, we have hydrogen at the cathode and bromine is at the anode. Now the reason for this is because it's an aqueous solution, which means that the potassium and the bromine is also going to have hydrogen and hydroxide ions mixed in. Because hydrogen is less reactive than potassium, hydrogen is given off first. So the key here in any question is to find out, is this molten or is this aqueous? And this question tells us it's aqueous, so it's dissolved in water. Explain why copper is formed at the cathode during the electrolysis of its salts. It's because the copper ion has a positive charge and is attracted to the negative electrode. So there are 2 pieces of information there, 1 mark for each. Okay, the test for oxygen is a glowing splint that relights. Test for hydrogen is you put a lit splint into the gas and you get a squeaky pop. Part 2, why is hydrogen and not magnesium produced at the cathode? It's because the least reactive positive ion is always given off first. And in this case, it's hydrogen. Because hydrogen is less reactive than magnesium. They're both positive ions, but hydrogen's less reactive, so it comes off first. Part C, give a reason why metal spoons are sometimes silver plated. It's because they're cheaper than solid silver spoons. And also silver is shiny and it resists corrosion. It looks nice. Student found the metal spoon eroded, I think that should say corroded really, and a thin layer of copper formed on the pure silver electrode. So copper forms on this silver electrode here. Suggest 2 changes that the student can make to this apparatus to make or to be able to silver plate a metal spoon. So 2 important pieces of information. The current is flowing the wrong way round. We know this because copper is coming out of the solution and coating this electrode here. We don't want this one coated, we want this one coated. So we change the flow of the electricity. So this becomes negative and this becomes positive. Okay, that's the first change we make. Second change, we want to get rid of the copper sulfate solution and we want to replace that with a silver ion solution. So any silver compound that's dissolved. Okay, that way silver from the solution will be attracted to the negative electrode because we've changed the current round and it will coat the spoon. Why is it difficult to electroplate plastic spoons? It's because they don't conduct electricity. When zinc chloride is molten, it will conduct electricity. And it can do that because the ions are free to move and carry a charge. Name the product formed at the positive electrode is chlorine. So this is the positive electrode. Chlorine ions go across and make chlorine gas. Explain why zinc ions move towards the negative electrode. It's because they're positively charged and opposite charges attract each other. So we had this one before, earlier on. 2 marks for 2 pieces of information. Because the zinc ions gain electrons, it's reduction. And we know this by using oil rig. Oxidation is loss of electrons. So if the ion loses electrons, it's been oxidized. If the ion gains electrons, it's been reduced. Okay, so the zinc gains electrons, so it's been reduced. This is a throwback to C3, looking at alloys. The reason why this alloy is harder than the pure metal, it's because the larger atoms disrupt the regular pattern of the metal atoms. This makes it harder for the atoms to slide over each other. So there are no lines of slip here, or very few. Whereas here you've got lines of slip, so these can move over each other quite easily. That means this is softer, that one's harder. Alloys can be bent. Some alloys return to the original shape when heated. What is the name of these alloys? It's shape memory alloys. Iron is extracted in the blast furnace. Calcium carbonate decomposes at high temperatures. Complete the word equation. Well, calcium carbonate breaks down and it gives us calcium oxide and carbon dioxide. Carbon burns to produce carbon dioxide. So here we need to balance the equation. So we have 2 carbons and 2 oxygens on that side. We have 1 of each on this side, so we need to double that. So now we've got 2 carbon, 2 oxygen, 2 carbon, 2 oxygen. Carbon monoxide produces iron 3 oxide. Now, this is a difficult calculation. The first thing we need to do is work out the formula mass of iron oxide. And we do that by adding together the masses of all the atoms in the molecule. There are 2 iron and 3 oxygen atoms. So if we write their masses, 56, 56 for each of the iron, 16, 16, 16 for the oxygen, add them all together, it gives us 160 grams. So we know that 1 mole of iron oxide has a mass of 160 grams. So the first thing we do is convert the mass that we're given, which is 300 tons, into moles. Now I'm going to ignore the tons bit for now, okay? I'm just going to use the number 300. So the mass divided by the formula mass is 300 divided by 160. We've got 160 back here. 300 is the mass we are given in the question. That gives us 1.875 moles. So we know we've got 1.875 moles of iron oxide here. The reacting ratio we get from the equation. So 1 mole of iron oxide produces 2 moles of iron solid. So 1 mole produces 2 moles, so the reacting ratio is 1 to 2. So 1.875 moles of iron oxide will make twice as much iron. So all we've done is double that number. Now we're going to convert that number of moles of iron into a mass. So we do that by multiplying the number of moles, 3.75, by the atomic mass of iron, which you can find on the periodic table. That's 56. So 3.75 multiplied by 56 gives us an answer of 210. Now, it already gives you the units here, so we just put our number in. Electrolysis of aluminium. Why can aluminium not be extracted by heating with carbon? It's because aluminium is more reactive than carbon, so carbon cannot displace it. Explain why aluminium forms at the negative electrode. 3 marks for this. Aluminium ions have a 3+ charge. So they are attracted to the negative electrode because opposites attract. So 3 pieces of information there. 1 mark there. 1 mark there. 1 mark there. Explain how carbon dioxide forms at the positive electrodes during electrolysis. So how does carbon dioxide form at the positive electrode? It's because the O2 minus ions are attracted to the positive electrode. The positive electrode is made of carbon. The O2 minus ions lose electrons and they make oxygen gas. And the oxygen gas reacts with the carbon to make carbon dioxide gas, and it gradually wears away the carbon electrode.